So you might be wondering about now, like, is she ever going to get to the point? And remember, the point is we're trying to find some value for a generating function, which is the coefficient. And I'm getting there, I promise, but we do need to review one thing that we already know, and then basically look at what happens in different iterations of the binomial theorem. So we do know the binomial theorem. We learned about it in this course. We've learned about it in other courses as well. So hopefully it's something that looks super familiar to you. 1 plus x to the nth power can be rewritten as the summation as k goes from 0 to n of n choose k, x to the k. So for instance, if we're dealing with an n of 4, let's say, then I'm going from 0 to 4, and a to the nth, which means that coefficient is going to be 4 choose k. And again, 4 came from the fact that n is 4. So 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. But let's say I want to keep going because let's say I have 4 choose 5, 4 choose 6, etc. Well, what's going to happen? I'm going to get my 1, which is 4 choose 0. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is 4. 4 choose 4 is 1. Anything where k is greater than n is going to result in a 0. So this would be the series that I would come up with using the binomial theorem. And because this is, of course, the binomial theorem, that of course means that I don't have to have one of my terms be 1. I could have 2 variables, or I could have the 1 be some other number. So essentially I'm looking at 2 terms instead of just 1. And essentially that means that whatever the first value is going to be to the kth power, and whatever the second value is going to be to the n minus kth power. So for instance, using the binomial theorem, let's say I wanted to solve this. I want to know, and again, what does this mean? That means what is the coefficient in front of x to the 4th if I were to multiply this out. 3x plus 2 times 3x plus 2 9 times. Now this would be a pain in the butt if I did this 9 times. So instead, let's use the binomial theorem that says, hey, do this. This is 9 choose 4, so that's 9 factorial over 5 factorial, 4 factorial, which turns into 126. And then x to the k, so that's 3x to the 4th power. And so really I'm saying 3 to the 4th, which is 81. And then y to the n minus k, so 9 minus 4 is 5. So really I'm saying take 2 to the 5th power, and 2 to the 5th power is 32. If I multiply 126 and 81 and 32, I get 326,592 and x to the 4th. So what am I interested in? The coefficient. That's the answer that I'm looking for. Again, instead of multiplying it out, I just use the binomial theorem. What I want to do now is take a look at the same binomial theorem. We're not changing anything, but we are going to write it a little bit differently. It's still the same theorem. And I want to use it for things that maybe don't make sense in real life. So, for instance, if I wanted to choose -3 choose 2 or 1/3 choose 4, those things don't make sense in real life, but you'll see once we get to where we're putting this all together why we need this extended binomial theorem so that we can calculate ideas like this. So here's our normal binomial coefficient. N choose k is n factorial over k factorial n minus k factorial. Now as you can see, if I take the numerator and I just start expanding it, n factorial means n times n minus 1, etc. And I keep expanding that all the way to n minus k factorial. Then at some point I'm able to cancel that n minus k factorial on the top and the bottom, which leaves me with this. And so essentially what I'm saying is n times n minus 1, etc., all the way down to n minus k plus 1 over k factorial is another way to write this. Now, when would I do it that way? I'll show you. Say I want to find 5/3, choose 3. So what I'm saying is start at 5/3, then take 5/3 minus 1, then take 5/3 minus 2, etc. Now, obviously this is the same as minus 2, and if you're confused about how many places to go to, remember we're choosing 3, so I'm going to have 3 terms on the top here. So it's 5/3 times 2/3 times negative 1/3, and don't get freaked out by the negative, that's going to happen. The denominator is still k factorial now, so 3 factorial. So if I multiply all of that out, I have negative 10/27 over 6, which is negative 10 over 162, or negative 5 over 81. Now again, you might be thinking, she's lost her mind. Now I've got a negative value. But again, I promise you this will make sense once we get to the point where we're actually using this in a question. Let's take a look at another example. I've rewritten the extended binomial theorem for you at the top, but the question now is, what if n is negative? Negative n choose k. Again, does that make sense in real life? No, I can't have negative 7 of something choose 2, but in mathematics it can make sense if we're just applying a formula. So think about if I had a negative n, really I just have a negative n on all of these values, which I can then factor out the negative. So essentially I'm factoring out the negative how many times? K times, because that's how many values I have in my numerator, is k values. So negative 1 to the k, and then all of this stuff, which looks like this. And if you'll notice, this part is just my combinations with repetitions model, n plus k minus 1, choose k, which is super interesting. And then of course we just have to take it times negative 1 to the k, because that was not part of our original function. Let's take a look at how we might use this. Let's say I wanted to expand negative 6 choose 3. So negative 6 choose 3, again using this extended binomial theorem for negatives, I'm saying let's take n, positive n, which is 6, plus 3 minus 1, choose 3, and then of course negative 1 to the third. Now we know negative 1 to the third is really just going to give us a positive or negative based on if it's an odd or even k value. So obviously if it's an odd k value, our answer is going to be negative. If it's an even k value, our answer will be positive. So what I have here then is 6 plus 3 is 9, minus 1 is 8. 8 choose 3. And of course the answer is going to be negative because negative 1 to the third is a negative 1. So there's my solution. Again, could I go ahead and find that solution? Of course, but we're more interested in computing or showing the correct way to find it as opposed to actually getting your calculator out to find what 8 choose 3 is. Before we start using these theorems in actual questions that we're going to do, and I promise I'm going to put it all together for you very soon, I want you to just practice using them so that that's not a stumbling block when we get to, of course, the hard part where we actually put everything together. For the first one, and again, I encourage you to press pause, try both of these questions, and then press play to see how you did. For the first one, I'm looking at a negative value, so again, I'm focusing on this one. And this one says, take 4 plus 2 minus 1 over 2, or choose 2, and then negative 1 to the second. Now, do I care about the negative 1 to the second? Negative 1 to the second is going to be positive 1, so I really don't care. So what I'm ending up with, and you can go ahead and write negative 1 squared. 4 plus 2 is 6, minus 1 is 5, so my answer is really just 5, choose 2. For the second one, and again, I've already uncovered the answer here, obviously, but I would just look at this extended binomial theorem. 1/2 choose 2 means I start at 1/2. I'm having two values, so 1/2 minus 1 is negative 1/2 over 2 factorial. That gives me negative 1/4 divided by 2, which is negative 1/8. So you can see I have found both of my values. We are almost there. So when we put this all together, I'm actually just going to give you the story problem, and then you're going to have to do what we did in section 9.1, which is come up with a generating function, and then all of the stuff we've learned in 9.2 so far, which is rewrite that series in a more, I don't know, easy to deal with way like this, and then use that to find the actual coefficient. So use all of these strategies that we're talking about. So we are almost there. We're just going to put it all together in a little bit, but here's a really good preview. The first thing I would do here is remember, this is telling me I'm looking for the coefficient of x to the fifth. I'm going to rewrite 1 over 1 minus x to the third as 1 minus x to the negative third. Now, what I just learned about dealing with negatives tells me that this is going to be negative 3, choose 5, and then I'm going to have negative x to the fifth. Because again, I've got my fifth power here, and this is going to be a negative x to the fifth. What I know about negative 3 choose 5 is that it's actually 3 plus 5 minus 1, choose 5, and then negative 1 to the fifth. And what I know about, let's make this a different color. What I know about negative x to the fifth is that I really can write it as negative 1 to the fifth, x to the fifth. Now, why does that matter? Because x to the fifth, do I care about it? No. It's not going to change my coefficient. It's just telling me that x to the fifth is going to be the variable value, and I'm only looking for the coefficient, which is all of this. So if you'll notice, negative 1 to the fifth is going to give me negative 1. This is going to give me negative 1, and negative 1 times negative 1 is positive 1. So if you'll notice, I've canceled out my negatives. So really, I just have 3 plus 5 minus 1, which is 7. Choose 5. That is my final answer. So again, we're putting all of this together to find 7, choose 5. Now, if I were asked to, of course, I could find 7 factorial over 5 factorial 2 factorial, which would be 42 over 2, which would be 21. But typically, 7 choose 5 is all I'll be looking for. Let's take a look at another one together. This one should be simpler than our last one. Notice here, this is n, this is k. So what I'm really looking for is 4 choose 3. And because I've got a negative x to the third, or a negative x to the k power, this is really what I'm looking for. And just like before, I really don't care about the x to the third, because that's just telling me that it's going to be the coefficient for x to the third. So I don't even really need to write that x to the third. So what this tells me is my solution is going to be negative 1 to the third, which is a negative, and then 4 choose 3. That's my final solution. Now, I've written some other things that will help us to look at just how we might write this generally. So again, I want to go back to where did we start with this in section 9.1? Section 9.1, I gave you a list like this and said, hey, come up with a generating function, and we would have to come up with something like this. So I just want to kind of tie it back to where we started so you don't think I've completely gone off the rails here. This would be our expansion going all the way through 12 because we've got 4 times 3, which is 12. And again, we might even write this as a piecewise function, but really that part is not as important to me as you understanding right now just how to find the negative 4 choose 3.